Now let's take a look at the sample problem 22.03. So the figure 22-13a shows plastic rod with a uniform charge minus Q. This bent in a 120-degree circular arc of radius r and symmetrically placed across an x-axis with the origin at the center of curvature P of the rod. In terms of the Q and R, what is the electric field E due to the rod at point P? So you're sitting on the observation point P, and there's plastic rod with a charge minus Q. This arc has the 120-degree circumference along the circumference. The 120-degree extend from 0 to 120-degree along this circumference of this arc. So we want to actually estimate the electric field exerted by this arc line charge onto this observation point P origin. So let's take a look. So first step is we gotta just estimate the charge element first. So charge element of this arc is dq, which is the charge density lambda times the length of small line element in this line charge ds. So that should be like this. The line that the density, charge density on this line charge is lambda, and we are looking at electric field from this small line segment ds. So the total charge should be lambda times ds. The fractional charge out of this arc. So total charge is minus q. So if you integrate this dq along this arc, that should be minus q. The next second. Now we want to just set up the equation of element field from this line elements. That is dE, the field from this line element. So that is 1 over 4 epsilon naught times dq over r squared. Now you want to replace this dq with the lambda ds. That is 1 over 4 pi epsilon lambda ds over r squared. So now we're going to sum them up along this arc. So the next step is summing of this line element along the x-axis. So you have electric field from minus 60 degree. This is like the charge line element of charge from minus 60 degree to the plus 60 degree. But let's take a look at the x component of electric field of this line charge. So that is dEx, which is d times electric field cosine theta. That from the number 2, that should be 1 over 4 pi epsilon naught lambda r squared cosine theta ds. So next step, you just replace ds with the angle. So as you know, circumference is radius times theta. So here the s and the theta they are all just variables. So if you take a derivative of this equation, then that should be ds equals r d theta, because r is constant value. So that could be out of derivative. So if you replace ds with this r theta, r d theta, then the electric field should be integral of d ex. So you want to estimate now the electric field out of this total line charge from minus 60 degree to the 60 degree. That is lambda. Oh, 1 second. So that is integral from minus 60 degree to the 60 degree, and the 1 over 4 pi epsilon naught lambda r squared cosine theta d r all d theta. Now you can take all the constant value out of this integral, only leave variable which is theta into this integral. So take that constant value out of this integral. That should be lambda over 4 pi epsilon naught r, because the r is cancelled from numerator and denominator, only leaves r on denominator. So that changes the equation from integral from the minus 60 to the 60 degree, and cosine theta and d theta. So here this one is integral of cosine is the sine theta. So now this equation could be replaced with this sine function, which is sine theta from minus 60 degree to the 60 degree. 60 degree same as pi over 3. So this one sine pi over 3 minus sine minus pi over 3. So that is result in lambda over 4 pi epsilon naught r sine pi over 3 minus sine minus pi over 3. So that is same as 2 times sine pi over 3, and this one is square root 3 over 2. So that is same as this one is just square root of 3. So if you add them together, then that should be 1.37 times lambda over 4 pi epsilon naught r. So that is just the electric field magnitude applied to the origin of P with the distance r from this arc shape of line charge. Okay, so now you want just to change that the lambda with the total charge, because the lambda is just alternating variable to drive this formula. So lambda could be expressed with the q, total charge q. So that lambda is the charge density. So that means you divide the total charge by length of the arc, then that should be the value of this line charge density. So that total charge q, and then the length of this arc is 4 pi r over 3. So that is 0.477 q over r. Let's replace lambda with this. Then electric field, total electric field E should be 1.37 times 0.477 q for pi epsilon r squared, right? Now you just replace this lambda with this result, and that electric field like this. So basically, if you just multiply 1.37 to the 0.477, then the total electric field component in vectorial space is electric field equals 0.834 pi epsilon r squared, and here q down here, then that is unit vector I. So because just like the previous problem, the symmetric line charge sitting on x-axis, and all the electric field from individual line elements create the two vector component along the x-axis and the y-axis. But if you look at the two line elements right there and right here, and if you decompose that electric field component, so basically that will be one from this line element, create the electric field is downward, and probably I'm sorry, that this direction. And the other one should be this direction, right? Because the negative charge, the field probably just inward to the line charge. But if you decompose this electric field that have this component on x-axis and y component, and this the field from second line element in symmetrical point that has also this electric field x component and y component right there. Just take a look at the two components from two line segments. The x components of these two vectors aligning in the same direction, so you should add them together, but y component of those two vectors are completely opposite direction, but the same magnitude. So they cancel out each other. So it leaves only x components. So if you integrate all the field vectors out of this line charge, only leaves the x component. There should be the no y component. So that's why you only have electric field, that x component. Okay, that's the answer of this problem.